Okay, let's get it. We are on part 2 of today's lesson, and we get to do a little math here, and it's not a lot of math. It's pretty simple, to be honest. I'm going to show you the best way to do these problems. I think some other teachers have some other ways to have you memorize a lot of stuff, and I'm not into the whole memorizing thing. I like to just try and make it simple for you. Okay, so I want you to kind of just follow me. You can track with me here. If you know these things, just watch. If you don't know these things, then just, press pause at different moments and copy stuff down. Okay, I want to make a clear distinction here that this is a right angle. Okay, and we know it's a right angle because it usually has a little box here, but it's like a perfect L. Okay, and right angles are 90 degrees. Okay, if you didn't know that, now you know. But it's a perfect L. Like you would know a right angle because like any box, any book, anything you have, like the corner of it is a perfect 90-degree angle. Any box, any book, anything that you have, right, that is, even like my little notepad here that I write on. Like if you look at the corner of it, it's got this L shaped. It's that 90-degree angle. You see them everywhere in life. Up here, back here, this little sign, where is it? Right, where can I get it with my finger? Right there, the corner of that sign that's hanging on the wall is a right angle. I mean, and every stinking where you look, you're going to see them. Okay, now, if we have two right angles, they're going to be the same. They're both going to be 90. Okay, now, when we're dealing, and this is only, listen, this is only when we're dealing with parallel lines, right, that are cut by a transversal. Okay, I want to make that very clear because I don't want you to take what I'm telling you now and apply it to everything because that's what some kids do. Oh, well, you said this. Oh, well, you said this. Okay, this only works with parallel lines cut by a transversal, which is what we're doing today. This is what we're probably going to do next week. Okay, so just be mindful of that. Okay, if you have a 90-degree angle, okay, and I make it smaller than 90 degrees. So I take this guy and now I'm going to make him less than 90. I'm going to close him a little bit. Okay, so I have that part of the 90. He's not going to go straight up. I'm going to close him a little bit. He's going to be smaller than 90, right? So this guy could be, I mean, anything that's smaller than 90 is called an acute angle, okay? Which means it's less than 90, less than 90 degrees, okay? And I'm going to call for this lesson, I'm going to call acute angles, I'm either going to call it acute or I'm going to call it small. Okay, it's small because it's less than 90. Okay, acute angles are less than 90. You need to be able to identify an acute angle, right? This guy here, and look, he's kind of closed. You can see that. It's like a mouth. He's closed. I'm going to call this either acute angle, small. I can even say closed down here. These are all words that I'm going to associate with this type of angle. And you need to be able to identify that, okay? Because an acute angle, like this guy right here, is an acute angle. He's small, he's closed, he's less than 90. Where's another acute angle? Okay, this guy right here. He's small, he's closed, he's less than 90. Where's another acute angle? Right here. This guy's small, he's closed, he's less than 90. Okay, where's another acute angle? He's small, he's closed, he's less than 90. Okay, you've got to be able to identify those. Okay, now I'm just letting you know, these are all the same. All of your closed angles, your small angles, your acute angles are all going to be the same in regards to parallel lines cut by a transversal. Okay, they will all be the same. So if I told you this guy was like 44 degrees, all the small angles are 44 degrees. This guy's 44 degrees, this guy's 44 degrees, and this guy right here is 44 degrees. Okay, they're all that. They all are. Okay, so that's like a game changer for you kids just to know that. Now, I'm going to show you something else. This 90, anything that's bigger than 90 is what we're going to do now. So we're going bigger than 90 now. I'm going to open him up a little bit. Okay, he's open, right? He's not a perfect L. He's not closed. He's open now. I opened him up. This is called an obtuse angle because he's greater than 90 degrees. Okay, in this lesson only, we'll call him a big angle, right? Or we'll call him an open angle. Okay, but this is his real name. Obtuse angle. This guy up here was an acute angle. Okay, that means he's greater than 90 degrees. So this guy could be 110 degrees. He could be 120 degrees. He could be 100 degrees. Anything greater than 90. So let me show you again, the same thing applies for him in regards to parallel lines cut by a transversal. If you can identify the open angles, they are all the same. So look, this guy here is open. He's obtuse. He's big. Where's another open angle? This guy right here is open. He's obtuse. He's big. Where's another obtuse angle? Oh, this guy down here is open. He's obtuse. He's big. Okay? And this guy right here is open. He's obtuse. He's big. So if I told you this guy's 110, you can just go and mark all of these guys 110 degrees. Okay? That's a game changer. All right? Because all the other teachers make you memorize. They make you memorize that, oh, alternate interior angles are congruent. They're the same. Okay? Alternate exterior angles are, you have to memorize all this junk, but I'm going to just teach you the shortcut. Okay? It's going to help you kids do well. Okay? The only other thing you need to worry about is vertical angles. Okay? Vertical angles are congruent. They are the same. They are equal. Okay? So I told you whenever we have an x, one side of the x and the other side of the x are called vertical angles. Okay, they're congruent. So if this guy is, I don't know, 98 degrees, that means this guy is 98 degrees. Okay? 180, 72. Okay, so if I told you this guy up here is 70, actually it wouldn't be 72, it'd be probably 82. 82 degrees. His vertical angle is down here at the bottom. He's 82 degrees. So vertical angles are always congruent. Now let's take what I taught you over to the lesson. I'm going to do 1 and 2, and I'm going to show you my reasoning. Oh man, corresponding. I forgot corresponding angles. Corresponding angles are congruent. Okay, and you'll see that here in a minute when I do number 2. So let's do number 1 together. Let's look at it. And I can recognize right off the bat, if there's 2 ways to do this, I can recognize that this guy is obtuse. He's an open angle. Well, guess what? They're looking for this guy right here. They're saying find the measure of this angle. Well, isn't this guy open? He's obtuse as well. So obtuse, right, and obtuse are going to equal, they're going to be the same. So this guy's 123. Okay. Oh man, there's going to be some, I got to teach you something else here down here in a second. So you got to pay attention. Number 2. These guys are corresponding angles. Another way to even check it out, like if you don't know they're corresponding, look, this guy's open. He's an obtuse angle. This guy's open. He's an obtuse angle. Okay? The obtuse angle, the big angles are always going to be the same. Okay? So if this is 133, that means this guy's 133. Okay? So I want to have you pause. I want you to try 3, and I want you to try 4. And then we'll go over them. All right, let's do it. So you can see for 3 that this angle here is obtuse. He's big. He's big because he's bigger than 90, right? He's 118. This guy up here that they're looking for, he's also obtuse. He's big. He's open. So if this guy's open and big and this guy's open and big, they're going to be the same thing. Okay, down here, this guy's small. This guy's small. Small and small are going to be the same. Or if you want to recognize, and you could say, oh, this is an X. This guy here and this guy here, they're vertical angles. They're congruent. Okay, so these guys are the same. They're 78. Okay, now this is where it gets tricky, but not even that tricky because let me show you. For 5, I'll put a star on 5. We have an open angle, right? A big angle, and we have a closed angle, which is a small angle. Here, but this one's different. We have a big and we have a small. So big and small are not going to be the same. Okay, big and small, they can't, right? You can't do big and small, it's not the same. So big and small have to add up to 180. So for number 5, you got to make a note that they add to make 180 degrees. All right, so what you could say is this is a question mark. You could say question mark plus 60 equals 180. Okay, so then you subtract 60 from both sides and you'd get 120. Right? Or if you know they add up to 180, you can just subtract. You could say 180 minus the 60. Okay? 180 minus the 60. So this is the kind of the game changer for the lesson that can be a little tricky, is that if you have a big and you have a small, they need to add to 180. Okay? So 6, let's look at 6. We have closed, right? They're going to be the same, so that's 88. Down here, try 7 and 8 on your own, real quick. Press pause, do 7, do 8, then you can press play, we'll go over them. All right, 7 and 8. Look, really closed, it's small. Really closed, it's small. Small and small are going to be the same. They're going to be congruent, so our answer is 54 degrees. Here, really closed, really small. Really closed, really small, right? Acute angle, they're going to be the same. So that means this question mark is 48 degrees. Really simple. Okay, we're going to take this concept next week and we're going to start throwing x's in there and we're going to solve for x and we're going to find angle measures. Okay, so, but we got to start it slow and start it easy. Okay, so you got your homework assignment right now, 10 questions just like these. Should take you no time at all, and then you'll be done for the day. All right.